Hey everyone, Mr. Voikin here. We're going to take a look at Unit 3, Lesson 4, 5, and 6, and we're going to learn how to do unit conversion. And we're going to start off by using this number line. So we want to familiarize ourselves with the number line, and this in the middle here that we're calling our base, that would be the units that we're working in. So it could be meters, it could be liters, it could be bytes, it could be volts, it could be hertz, grams, any one of those units. And all these other letters here like M, H, and G, those are what we call the prefixes. So these are the symbol or the letter that goes in front of the base. So I would have milligrams, millivolts, millibytes, gigabytes. And that determines helps determine the size of that number. Now this is a base 10 system, which means that every time I move along this number line, 1 space, 2 spaces, or 3 spaces, each time that we move that direction, the decimal place is also going to move 3 times. And if I move to the left 1, 2, 3, 4 times, then the decimal place in the number is going to move to the left. In this case, 4 times. Okay, so let's take a look at the question number 1, which is saying we have 63 kilometers and we're going to centimeters. So the kilometers are right there. The centimeters are right there. And how many jumps are we making? Well, 1, 2, 3, 4, 5. So if we're making 5 jumps, what we're going to do is start off with our number, which is 63, recognize where the decimal place is right at the end of it, and we're going to make 6 jumps, or 5 jumps. 1, 2, 3, 4, 5. So basically that decimal right there is going to move down to that position right there. And now we want to fill in those empty spaces with zeros. 1, 2, 3, 4, 5. So that is our new answer, 6,300,000 centimeters. Okay, the next one we're dealing with starting units of meters, and we're going to micrometers. And notice that the number is given to us in scientific notation, but we can still just take that number, which was 4.8, and again we need to take a look at the number line and see where we're starting and where we're ending up. So we're starting at the meter, which is the base, and we're going to micrometers. And how many jumps is that going to be? Well, 1, 2, 3, 4, 5, 6 jumps. And again, that decimal just needs to move 1, 2, 3, 4, 5, 6 times, which means that the decimal is going to move from that location down to the end, and all of these holes are going to get filled in with zeros. Now don't forget that we've got this times 10 to the 3 right here, so we still have to write that down here. So it's times 10 to the 3, and the answer would be, the units for the answer would be micrometers. Now if you start with scientific notation, you're probably going to have to put it back into scientific notation. So essentially what we're going to be doing is taking that decimal and 1, 2, 3, 4, 5, 6 times to get back to its original location. And the only reason it's going back to the original location is because scientific notation always has one digit in front of the decimal. So that's going to be 4.8. Now we had times 10 to the 3 before, but because I moved the decimal 6 times to the left, I'm going to add 6 to that number. So what we end up with is 4.8 times 10 to the 9. And again, don't forget the units, which are micrometers. Now, if we take a look at the example up above in question number 1, I've got 6,300,000 centimeters. Again, it's a very large number, and it's probably better to represent that in scientific notation. So again, there's my decimal. I know I'm going to end up with a 6.3 times 10 to the something. Just how many times did I have to move that decimal to get to the to get it in between the 6 and 3? 1, 2, 3, 4, 5, 6 times. So it's times 10 to the 6. So notice if we move this decimal to the left, then the exponent in the scientific notation is going to get larger. When I move it to the left, the exponent in the scientific notation is, we add the number of jumps to whatever was there. So let's take a look at number 3. It's not in scientific notation, but we do have the decimal in the correct location for that. So really this would be 5.86. Now I could just go times 10 to the 0. Now remember that anything raised to the power of 0 equals 1. So essentially what we're saying here is 5.86 times 1, which is just 5.86. So putting times 10 to the 0 doesn't change anything. Now let's take a look. Where are we going from? We're going from and to. We're going from gigabytes to bytes. Okay, so let's go back up top here again, and let's see where we're starting off. We're starting off at gigabytes, and we're going to bytes, and that would just be our base. And how many jumps are we making? We're going 1, 2, 3, 4, 5, 6, 7, 8, 9 jumps to the right. Okay, so if I'm going 9 jumps to the right, that means this number is going to, I'm going to have decimals that are going in that direction. Sorry, didn't write anything, in that direction. So what I'm going to want to do is, instead of actually adding all these zeros and then bringing them back, let's just do what we did in the previous two, which is, I know that I'm going to have a whole bunch of zeros, which means I'm going to need to bring it back to the left when I'm done, the number of jumps that I'm going to make. So I'm going to add to that. So it will end up being 5.86. And now because I'll be coming back, sorry, I forget how many jumps we made. 1, 2, 3, 4, 5, 6, 7, 8, 9 jumps. I'm going to basically take that times 10 to the 0, and I'm going to add 9 to it. So our answer is going to be 5.86 times 10 to the 9, and our units are bytes. Okay, so I'm going to do one last one here, number 4 with you. This one will be moving in the opposite direction. I will provide answers for 5 and 6 before we move on to the next one, which is proportional ratios. Okay, so let's go take a look where we're going from and to. So we're starting at nanometers and going to kilometers. And I'll just erase this really quickly up top here. And again, just to illustrate, we're starting at the N and we're going to the K. And how many jumps is that going to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 jumps to go between those units. So notice all the other ones were moving on the number line to the right, and that caused that, or sorry, to the left. Oh no, we were moving to the right. We were moving to the right, and that caused us to add to the exponent that's on the in the scientific notation. And now we're actually moving to the left, and just think about the x-axis, that number, the numbers there, every time we move to the left, they decrease. So basically what we're going to do is we're going to subtract the number of jumps, which is 12, from the exponent there. So we have 1.2 times 10 to the 21, and that's going to be, we're going to subtract from that 12. So we're going to end up with 1.2 times 10 to the 9, and the new units that we have are kilometers. Okay, so I'm just going to quickly pause the video, do the last two questions, post the answers on there, show you, and then hopefully you're not having any problems, but if you are, you're going to need to come and see me. Okay, so I've done the last two questions, number 5 and 6. So 6.05 micrometers is going to be 6.05 times 10 to the negative 6 meters, and 7.8 times 10 to the negative 4 megaliters is going to convert to 7.8 times 10 to the 5 milliliters. Hope this helps. Good luck.